Well, hello, we're back here. We just finished going over this example and figuring out what DG and BF are. And we're going to go ahead and look at the next problem here. This one's already worked out for us. In example 3 here, they're asking to place a square and a right triangle in a coordinate plane in a way that it is convenient for finding side lengths, the side coordinates to each vertex. So we have a square with side A that we're going to go ahead and look at here. And we're going to place it on here. So if we use the vertex, it makes it much easier. And we put one base along the bottom and we say, okay, this is length A, so the coordinates of this other corner are A, comma, 0. And then we can go up A also and put another corner there. And we can put another corner here. So this is up A, this makes this side's A, and it's 0 in the x direction, so we have 0, comma, A for that corner. And the fourth corner, which is over here, is both A and A, so we get A, comma, A for the fourth corner. That's placing it where it's convenient. You could place it anywhere else, but then you'd have to do stuff like x plus A and x plus A up and over. We're going to go with the simple. Always place one corner on the vertex, makes it much simpler. For instance, we have this right triangle here we're going to place with a length of A and a length of B. The legs are A and B. So if we stick the vertex here, one corner here, and we call this side length A, we get the next vertex at A, comma, 0. And then we go up B, that would give us 0, comma, B as the next vertex, creating our right triangle with legs of A and B. Notice that C can be found using the Pythagorean theorem, or you can use the distance formula to find the length of C, side C, which would be down here. I personally prefer the Pythagorean theorem. Distance formula works great too, though. Going on to the next slide, let's see what we got here. This says place on a grid a scalene triangle. Remember, a scalene triangle is one with 3 different leg lengths with side lengths B and C, a base of length A, and a height of length D. So side lengths B and C and a base of A. So here's the base of A. And notice this vertex here is A, comma, 0. And the other vertex is A, comma, 0 also. Oops, 0, comma, 0. And that's at the origin. And we have our height of D here. And they said with side lengths of B and C. So this would be B and C here. Now the trick in this is going, so the height, because it's not an isosceles triangle, it's a scaling triangle, the height won't be in the center. And that's going to be labeled D because it said a height of D here. So the coordinates for this point, we'll go ahead and use this trick and call that distance x. Will be x, comma, 0. And how much did we go up? We went up D, that's the height, so we get x, comma, D for the other vertex. And place on a grid again. There we go, done. Next triangle, once again, the trick here, use your origin, 0, comma, 0 as one of the vertices. Let's go ahead and look at the next problem here. In this one, they said place a rectangle in the coordinate plane, then find the length of A diagonal on the coordinates of the midpoint M. So we have our trick here. Use one vertice. We have A, comma, 0 as another vertice, and 0, comma, B. That gives us a length of B and a side of A. And then A, comma, B as this fourth vertice. There's our rectangle. And to find the distance between these 2 points here, this red dashed line, we're going to go ahead and use the distance formula. And we have the distance formula right over here. And we simply go 0 minus A squared. 0 minus A squared, the difference in the x's plus the difference in the y's. That'd be B minus 0. Or 0 minus B. I'd probably be consistent and go 0 minus B squared. And when you square that, the negative sign disappears, so you get A squared plus B squared. Midpoint formula is simply our average of our x values, which is A plus 0, all divided by 2, and the average of the y values, 0 plus B divided by 2 for those 2 corners. Going to the last problem here, we have find the length x there. Use your midpoint, your mid side theorem there. And